Hey guys, it's me, Callum Matthew again. I was just texting my girl Alexis about some other mechanisms that can change a population. You want to talk about them? Alright, sweet. Y'all remember how natural selection works, right? There's all this inherited variety in any population. Also, more offspring are born than can possibly survive. So, this will cause a big competition for the resources in the area. Because individuals are different, there's going to be a big difference in who lives and reproduces, and who dies before they get a chance to mate. That's going to change the population. After some generations, the whole population will eventually have the most favorable traits. And that's how natural selection changes populations. But there are some other causes too. First off, you have just plain old randomness. This mechanism is called genetic drift. Sometimes, the genes of a population can change for no good reason at all. Let's look at that definition. Think about this. What if a population of birds was migrating past an island? Let's say this population has mostly orange individuals, but also some purple ones. Well, what if as they're flying by, some big gust of wind comes across? What if some birds get blown off the course and land on the island? Maybe for no good reason. There's more purple birds in the new population than orange birds. This new population is definitely different than the original. Is the purple trait more favored than the orange one? Nope. It's just totally random. A lot of times, natural disasters can change a population. A forest fire might kill off more individuals of one trait than the other for no good reason. The next generation of squirrels or whatever might have more gray individuals than before, even though there's no really advantage to gray. There's another way a population can change, and it's not genetic drift. It's called gene flow. Now, don't go and get these mixed up. Gene flow happens when individuals from one population will move into a different population and then spread their genes. It's like the genes are flowing from one place to the next. Look at it like this. Let's say we have two populations of the same species that are separated. We got the reddish population over here and the small population of green guys over here. What if some red individuals move into the green population? Well, over some generations, we're going to see more red guys in the new population than before. It's not like nature was selecting the red trait over the green trait. It just happened that some new genes were introduced, and that's obviously going to change the population. In nature, this happens when a group of the same species gets separated by natural events. A river might cut a meadow in half. So you get some plants over here and some plants over here. The populations will probably change over the generations. Natural selection, right? A strong windstorm might spread the pollen across the river into the other population. After some springs go by, the entire genetic makeup of the whole population is going to change. You see the pollen float in the wind across the river and into the other population. This actually happened with pollen blowing over the Great Wall of China. Whoa, cool. There's another way the genes of a population can change, and it's so obvious you might overlook it. What about genetic mutation and recombination? We know that mutation is when there's a change in the sequence of DNA, and recombination is just the shuffling of the genes. If two purple parents reproduce, we'd expect the offspring to be purple, right? What if a mutation happens and there's a change in the DNA of one of the offsprings that gives her a yellow phenotype? If there's no advantage or disadvantage of this appearance, then there will probably be more and more yellow individuals in the population, right? Duh. This new yellow phenotype might also be produced by recombination. Gametes like sperm and eggs are made during meiosis. Often, whole chunks of chromosomes are switched. This is definitely going to cause new gene combinations in the offspring. Either way, if the starting population is pretty small, then mutation and recombination could cause a pretty big difference in the population. So there you go. Although natural selection is the most powerful cause of evolution, it's not the only one. Genetic drift, plain old randomness, can cause a population to change. And then there's gene flow, where members of another population will move on over and spread their genes. Finally, there's genetic mutation and crossing over. This is where the offspring has a different phenotype than the parents. These new genes can stick around through the generations. So until next time, it's Kellen Matthews saying, when it comes to gene flow, you can keep the change. Bye, y'all.